There it is. Hello, everybody. Welcome aboard. We're doing it again. Big number 40, our 40th program in a series stemming way back to, I guess, the third month of this year, 2021. The Santa Barbara Astronomical Unit Astro Hour, shortened down to just SBAU.org when you get on our main line website. November 29th through December 5th, everybody. Welcome aboard. Happy Omicron variant. And it's Cyber Monday, and for any of our Jewish members of the club, it is the second day of Hanukkah. Santa Barbara's Astronomical Unit is our local South Coast Astronomy and Telescope Club. We got the main people involved here for our weekly Monday morning podcast, where we're going to talk about a couple of galaxies. We're going to learn a lot about things out in space. There's one or two star clusters in this week's program. And we have a visitor from the Comet Cloud, actually several out there, but we're going to talk about one of them. 3 planets are in line later on. We'll get into that. And if you can believe this, by golly, NASA's going to send a drone to Titan. That's the moon we're going to talk about, not our moon, but we're going to go to Saturn's system. Gentlemen, let's meet everybody. President Jerry on my screen is in the middle right. Jerry Wilson.
Good morning.
How's Pat? Your lovely
Good,
wife, Pat.
good.
She out cyber shopping? Well, that's done at home tonight. You don't go out.
No, she's out supervising our garden redesign.
Oh, good for
The
you.
crew here this morning.
All right. I hope they haven't passed any new laws in your home association that you have no control over, since you're not president anymore. We got our outreach coordinator, Chuck McPartland, on board.
Hello, good morning.
He's also married to a Pat, our merchandise manager, Pat McPartland. Tom Totten runs the show, our webmaster, in the upper left of my corner, could be anywhere. And his lovely wife is Suzanne, an artiste. Bruce Murdoch, wife of Lonnie. Hello, Bruce. And this week, I told you most of the things we're going to talk about. I'm going to let the president take over here in a second and guide us through this. But I just wanted to say the December newsletter just got sent out to our email inboxes by our hardworking treasurer, Colin Taylor, who would love to incidentally relinquish that job if anybody might want it. But it's edited by Tom Whittemore. He's going to be joining us any moment now, as soon as he gets the sourdough bread out of the oven. One of the items in that online newsletter, we're going to, I guess, dispel Mr. Chuck McPartland. We are not having a December star party on the second Saturday, are we? As it said we might.
In the newsletter, it does say that we are going to have a star party in January. So the newsletter is fine.
Oh, okay. I didn't get that far. I didn't see that for some reason.
Yeah.
Jerry Wilson's monthly article is about protocol and setting up a scope and taking pictures, right, Jerry?
Yeah, that's yes. I finally settled on a design, or rather a procedure that I found works very quickly and accurately. So I can set up telescopes at remote sites at campgrounds, not for public viewing, but for me to take pictures, such as at CalStar or something.
In 15 steps. Okay.
Yep. I added step 8 just to remind myself.
Okay.
Because I've taken a few pictures with the Batinoff mask still on and didn't notice it at the time.
Would this be something that would be a good subject, or has it been, for the weekly telescope workshop, which is always Tuesday? It's tomorrow night.
Yeah, we can discuss that tomorrow night at the workshop.
7:30 to 9.
I've received an email from one of the workshop people about his opinion on how I could improve things.
Okay, and to find out how to join in on that for members, go to SBAU.org, Tom Totten?
Here, that'd be the great place to go. Yeah, and there's a contact page there.
Can the members join in, or do they just get to watch like they're doing on YouTube?
Oh, no. It's a group discussion.
Group effort. Okay, there it is, our beautiful newsletter. Tom keeps cranking it out. The other Tom, Mr. Whittemore, has not joined us yet, but he should be with us.
Yeah, I wanted to compliment Tom Whittemore on his captions for some of the photos that he chose for the newsletter. So he got.
I love that thatched roof observatory.
Yeah, that was a good one. Joe Doyle looking at it. That's pretty funny.
That wasn't Joe Doyle. That's a guy who moved to Colorado that used to be in the club.
Let's go back there for a second. Let's see if we can see that.
Here is the caption. Here's the caption I noted. I'll read it to you. I'll let you look at the picture or just look at your email. Sorry, Farshad. It says here the next
Oh, yeah.
transit of Venus will occur when you're 252 years old. Sorry about that. You're an old man, not like you are now. And right
And then
below that
here's
is
the one with the,
yeah. And there's Jerry's. You know, this first time we've ever really looked at our newsletter. It's a pretty darn good newsletter. Got
In color, too.
Yeah, all the color.
We need
We're not printing them.
we need to add a comics page.
Yeah. We used to have them pretty regularly. Tom used to actually draw some of them.
Oh, okay.
Gather up all those forwarded cartoons. Gary Larson, except would be hit with.
Now, if we print them like that, we'd have to have copyright permission, I think.
Yeah.
Well, I used to do cartooning. I got a little bit of that
We
behind
can
me.
do our own.
Apparently, Tom Whittemore, who has yet to join us and may or may not be on board, also includes a guy named Ted Kuzer. He usually does poems. This month, he has a piece of prose that's rather bizarre, and I'm going to just read the opening line, or it starts out, the garbage truck tires had left 2 keyboards impressed in the snow. You're going to have to go online and read the rest. We're going to talk about the last variable star of the month, the demon star Algol. Going to show you pictures of Hyades. As we mentioned, a couple of star clusters. Where would you like to start, Mr. President? Just curious.
Oh, no, you pick it. You're the MC.
All right, well, let's do it in order like you sent it to us. We got pictures of the Hyades.
Yep.
In the north sky. Tom, while you work on getting that, a young star cluster, 150 light years away in the nose of Taurus the Bull, whose stars are 625 million years old. Just let the bull's bright red eye, Aldebaran, guide you. It sits nearby, not part of the cluster. In fact, it's closer to us, I think. You want to tell
It's
us
like
what
65 light years away.
But
Did Jerry take this picture?
No,
Oh, okay, because it's a really nice picture.
thank you, but no, I haven't done that.
hmm,
That's a very wide field of view, you know, the Hyades.
I know.
is a big open cluster.
Yeah.
I only see it in my finder scope, which is 25 power. It's too
Yeah.
big for my main scope.
Yeah.
That's the full face of the bull.
but Aldebaran is a big aging red giant, 70 light years away.
Yep, that's the one on the left.
Is that what that is?
Yeah.
Get this. This is what you sent us. The 14th brightest star up there, 43 times bigger than our sun. If it were in the center of our solar system, it would take up 20% of the sky. Good Lord. But not big enough to include us to suck up the Earth, right?
It would
Would
reach
be-
up to about Mercury.
Oh, it would be past Mercury. Okay. That's amazing. See, there's
There are
red
stars
giants.
much, there are
What?
stars much bigger, but this is still very big compared to our sun.
Oh, yeah. Do you know the name of the biggest that they've seen? If you
Oh,
go
it keeps
through-
changing. There was VY Canis Majoris and a bunch of others. They're Mu Cephei. There's a bunch of them that are huge.
Okay, well, are we going to be talking about Hyades or Aldebaran, the star?
Oh, this is just about the Hyades cluster.
Okay. There's another cluster we'll be talking about later on, the Beehive, where a comet is
Yeah.
located.
That's the other big, what are you showing, Tom?
I was just looking for some information on Aldebaran.
Oh,
Is that how?
Last time we were up at Figueroa Mountain, I saw this star cluster that was just above the mountains about to set. And I looked it up and looked it up. It was the Beehive, and it's big. To
Yeah.
the naked eye, you can see it.
yep.
The Greeks used it for weather prediction. If you could see it with your eyes, it probably wasn't going to rain the next day.
Yeah.
Is that right? And it only has 360 something stars in it? Is that the one?
Well, wait, which are we talking about? The Hyades or the
I'm trying to find
Beehive?
my notes. I think it's the Beehive, right? Or is,
Well, wait till we get to the Beehive. This is the Hyades,
Yeah.
all right.
the one
So,
in Taurus. The stars that you see in there, the blue ones and the smaller yellow ones, those are all part of the cluster. And you can see in the background, you can see these are dark nebula. And then there's thin dark nebula in the background. That's these patches of kind of a brownish cloud that's there. And that's when you take images of the stars, being able to see those hazy clouds, those light brown clouds. That's quite a trick of processing to get those out of there. You've got a very good control of signal to noise in that. And you
Okay,
can see-
Aldebaran is a red giant, and
Yep.
there are more dwarf, little red, what do they call them? Red
Red
dwarfs.
dwarfs.
Red dwarfs, yeah.
Two totally different animals, even though they're
Yeah.
both reds.
Opposite ends of the temperature and size scale.
Well, they're at the same end of the temperature scale, but the opposite ends of
okay.
the
Okay. Well,
brightness.
let me finish with the brown nebulas. When stars form, they're in a nebula like the Orion Nebula, and then the stars turn on and the solar winds blow all the dust away. But in this case, there's still some dust left behind. So it's still getting cleared out and to become a pure star cluster.
Okay,
Okay, done.
wow. Talking about the size of Aldebaran, if it were in the center of our solar system, it would take up how many degrees? Several, I guess.
20.
Glows at magnitude 7.7, which is what, just barely seeable? Is that
No,
about
no, no,
as
no,
high a
no.
number?
Ron, 7.7 is Ceres.
Oh, it is. Yeah, that's okay. So, but Aldebaran is the 14th. Is that what it said, or 17th?
Yeah, it's a first magnitude star.
Oh, really? It's number one, magnitude
No.
1?
No. Well, it's close to 1.
Okay. But some of those numbers, like Venus, are minus.
Yes.
Yeah. No, it's the comment there that gets you confused with the Hyades and Ceres is that right now the dwarf planet, notice dwarf planet, not asteroid. The dwarf planet Ceres is passing through the Hyades right now. So it's an excellent photo opportunity with a camera lens or something where you can take a picture of the Hyades every night, and then you can see one of the fainter stars moving through every night. Or you could make a movie of Ceres passing through the Hyades. It's a great photo op.
Oh, I see. The asteroid series is moving. It's out
Well,
in the
for some
Milky.
reason, the astronomy magazine wants to call it a dwarf planet.
Well, it is, isn't it? That qualifies by
Yes.
definition,
It is.
It's one of the
Yeah.
5 official dwarf planets.
but the only one in the asteroid belt.
Yes, so far.
Yeah.
Okay. It must occult a lot. Have you been occulting lately, Mr. McPartland?
Yeah, I got a positive week and a half ago, and I'm trying one tonight.
You want to tell anybody that might be tuned in what the heck we're talking about? What is occulting? You
That's
didn't
just where
occult.
an asteroid passes in front of a star and makes it wink out. And so if enough people video it with accurate GPS information, you can map its shadow on the surface of the Earth and get its shape.
Did the star it occulted have a name?
Oh, it had a catalog name. It was a UCAC 4 star with a name something like 561000743. But
Oh, yeah, that one.
yeah,
One of those Neil deGrasse Tyson telephone numbers in the sky.
yes.
Well, shall we go to the other one in the Beehive Cluster? There is that gets us into comets are us. This is good old Churyumov Gerasimenko 67P, and it's coming our way. Actually, it's close, isn't it? It passed the orbit of Mars, but it's in front of the Beehive Cluster.
Yeah, this one's passing through the Beehive. So it's an opportunity, but not for a point of light moving through. You can actually see the comet as a comet.
And it's not on the ecliptic. It's going to do what Oumuamua did, right? Come down from somewhere else, like the Oort cloud.
I think most comets are not on the ecliptic. Correct me if I'm wrong there, Chuck.
Yeah, most of them aren't, because they come from an area that's not as influenced by the ecliptic. Some of them are,
Right.
if they're Kuiper Belt. It just depends where Jupiter tosses them.
But is it going to go inside Mercury's orbit? Is it going in close?
No.
It's
No.
not. So it's just
So the
about,
other one, Ceres was 7.7 magnitude. This comet is 9th magnitude. And it's a little harder to spot because that 9th magnitude is spread out over a sizable area. It's not a point object.
these two gentlemen for whom it's named, I guess, are holed up over in Russia. Churyumov, what's his name? Churyumov?
Churyumov and Gerasimenko.
Okay. But watching the Beehive Cluster, God, how many clusters are out there? Every week we do a couple of clusters. Bruce, did you say you took a picture of it?
Stop it.
Not, I didn't take pictures when we were up at Farron Road.
I've got my notes here, but I'm not sure if that's, you can see it with the naked eye. Do you need a
Yes.
scope?
I've seen it. I have seen it with a naked
Yeah.
eye, but you need a dark sky.
Oh, okay.
No, you're talking, Bruce,
binoculars
you're
are pretty
talking
good.
about the cluster. I think Ron was talking about the comet.
Oh no,
No, he's talking about the cluster, I think,
Okay.
right?
Yeah,
I
well,
don't know.
So
I've seen
the B-
Churyumov Gerasimenko, but I didn't. I'm not sure I photographed it. Was that quite visible a couple of months ago?
No, that's Neowise you're thinking of.
Yeah.
Oh, okay. Yeah, I got
Churyumov
pictures.
Gerasimenko never got really bright, but it's the one that was visited by the European Space Agency.
Oh, yes. Okay.
and it happens to be named by Mr. Messier, number 44.
That's the cluster.
Oh, yeah, right. I'm sorry.
The
That,
Beehive. Yeah.
It's 44, Ron.
what did I say?
24.
Did I say 24?
I thought it could be the
It
audio.
sounds-
I think
It's
it was.
44.
Was it? Yeah. Here's a phrase I've never heard before. I assume it has to do with the comet. Coma diameter 5 arc degrees. Or 5, not degrees.
5 arc minutes.
Minutes, I'm sorry. It's pretty small then, isn't it? That's the centerpiece, the center, the main rock.
No, that's the main area of fuzz, but the actual comet itself is invisible and tiny.
Oh, I see. Okay, so is there a tail on this sucker?
Yeah.
Okay.
So
But
what does this mean on this? What does this mean on this chart here? It says observed magnitude is 8.8, but the estimated estimated magnitude is 12.8.
Hmm.
What's the difference there?
There's estimated magnitudes based on how a comet's behaving and its distance from the sun. So this shows it's kind of doing a little more outbursts than they expected.
Oh, okay.
As we have learned in past shows, there's always several comets at any one time, most of them not seeable. Maybe this is the brightest. How many did you guys say a couple weeks ago are out there? 7 or 8?
Oh, there's probably 7 or 8 that are easily visible in telescopes, but there's hundreds at any given time.
Yeah.
Including, yes.
Including Comet Halley.
Oh, yeah, but Haley, is it coming back?
It comes back every 76 years.
Yep.
What is
And
this?
it's I think it's out near its maximum farthest away. And it has been photographed within the last year. It's just a very faint dot among very faint stars.
Okay,
Big telescopes can track it, measure its orbit.
so even though we know it comes every 78 years, we don't know the last time it whipped by us, went around the sun close.
Well, that was
Okay,
1985, Ron.
Oh, so it's on its way, probably still back at, well, wait a minute, 40 years. No, 30.
Yeah, it's probably already reached its perihelion. We're talking
Yeah.
about Halley here, right?
Yeah,
Yes.
Yeah.
and they all
Yeah.
come from the Oort cloud, right? Which is a
Well, Earth
shell.
cloud or Kuiper belt.
Or Kuiper belt. Okay. Well, there's one called Leonard. I don't know the deal on Leonard, except it's C2021A1 Leonard.
We talked about this briefly last week. It's the one that's coming in that's on a hyperbolic out orbit. So it got a boost from somebody that's going to toss it out, apparently.
What do you think, Chuck, that maybe because it loses mass as it gets close to the sun, then it's lighter and then gets thrown because it's lighter or something?
No, that won't do it.
Yeah, I don't think that's a significant amount of mass each time. I mean, it adds up over time, but
And it's not a mechanism that can change the orbit from closed to open.
yeah.
Wow.
If it got a real jet of something, that might help it a little bit.
Yeah.
Well, I'm not sure if Mr. Messier named it the Beehive, but that sounds like something we would have come up with later on after he.
Well, apparently it looks like, to some people, one of those dome-shaped beehives that you see in cartoons and stuff nowadays. But real beehives nowadays are these white boxes.
Yeah. That's a name that wasn't given to it until you had photography of it.
Yeah.
It used to be called Praesepe, or the manger. And there were 2 stars. You can see one at the lower left and one kind of at the right up there, called Acellus australis and Acellus borealis, that are 2 asses, 2 donkeys that are feeding at the manger, according to the little story that goes with it.
And it does look closer to a manger than a beehive.
Yeah.
Oh,
But
I'm
you can
cool.
see kind of the conical structure there. It's kind of
it's
upright in this
tilted.
picture.
It's on it. Yeah, it's tilted.
A mini
Oh, yeah.
Taurus.
And their
And then
word for,
a
their
lot
word-
of double stars are the bees, huh?
Yeah, there's a lot
Actually,
of
they're
nice
triple
triples in
stars.
it.
Yeah.
what'd you say, Chuck?
There's a lot of
what?
nice triple stars in it. I mean, they
Yes.
appear triple. They aren't necessarily triple as far as being gravitationally bound.
Okay, well, Jerry's note said the Greeks and Romans did call it Praesepe, or the manger in their language. And only 350 stars, that's nothing.
Are you getting jaded?
Well, aren't they clusters of thousands sometimes, or tens of
Frequently,
thousands?
yes.
Usually, yes, but let me get the details.
And that's probably just the ones that are easily visible in photograph. I'm sure, if you go deep, you can add a little to that number.
Yeah.
And Ron, this would be an open cluster compared to those closed clusters, which you call globular clusters.
Globular clusters, yeah.
Okay, so what's the difference? What does open mean?
Open clusters are young stars. Globular clusters are densely packed old stars, usually with tens of thousands of them.
And they have a way of figuring that out, how old they are.
Yeah.
So I
Looking at
have,
the
I have a question from Tim Crawford, and he says, one thing I'm confused on is that an object can have a magnitude that sounds visible, but because it's spread out, it is not really visible.
Yeah. Yeah, often with a comet's coma, they give an integrated magnitude. That would be if you took all that light being given off by the coma and you concentrated it into one point. So if it's really spread out, the surface brightness is actually quite low. That's like same thing for the magnitude of M33 that's behind Jerry there.
Galaxies.
Huh. What
There it
this?
is.
Perfect.
Does that big circle on the edge mean anything?
That's
What we're
the
looking-
field of view edge.
Oh, that's just the.
I guess not. There's stars outside of it.
Okay,
Oh, someone just drew
says-
it there.
but that's
So
our
here
beehive.
it says the area of the sky represented in the image is 3.6 by 3.6 degrees, or 217 by 217 arc minutes. So 3 degrees,
Okay, you could get 6 full moons in
3.6 degrees.
6 degrees, and you could get 12.
Mhm.
Wow. Well, that's fascinating stuff, gentlemen.
By the way, I just got a text from Tom Whittemore. He says they're having a plumbing problem, so he's not on today.
He needs to hook his computer up to the electricity, not the plumbing.
Should get these little items in the newsletter as news, bits. Would you like to ease out of this unless there's more to talk about into Cetus
No.
the whale? There's another M out there, 77, but guess what it is? Who wants to tell me what it is? Bruce, do you know what M77 is?
No, I've never looked for it.
It is
Asteroid galaxy.
it's a spiral galaxy way outside of our own galaxy. Rising in the east as the sun sets. A beautiful face on. To find it, you first find magnitude 4.1 delta Cetus. Cetus, how the hell do we? Let's see.
I've heard SETI.
Seti, okay.
Yeah.
And yet Cetus is how you pronounce the longer version. It's just south of Cetus's head, the asterism of the head. M77 is less than a degree southeast of the star, magnitude 9. Even small
Yeah, it's one of the brighter galaxies. It's easy to find in a small telescope where all the M's are. This one has, like M33, it has some real nice hydrogen zones in it. The red structures on the right and the spiral arm. It has 2 major spiral arms you can see, and
Really?
the right cloud, the cloud in the right hand arm is one of those hydrogen alpha regions. But you can see other little ones all around in the structure of the galaxy. It's a very nice object to take a picture of. Good and bright. Yeah.
Wow. They think our Milky Way is shaped like that? Is that a barred?
Not really. This one, I don't think this is a barred spiral. It's got a little ellipticity to the central, but we're a barred spiral. This is not.
Well, apparently there's some big black hole action in the center, more so than the rest of the galaxy. That's really bright. I believe that's what it said. Larger lens might be better than binoculars. 50, okay. 50 millimeter or more, okay. M77 appears as a dim oval-shaped glow galaxy spans 7 arc minutes by 6 arc minutes,
Mhm.
and it's 50 to 60 million light years away. Big black hole in the center, 10 million times the mass of our sun, Lord. So it's most galaxies have a little better spread out of the light. It's just slightly brighter in the middle. To this one, it does something else. It's really bright in the middle, right?
It is. It does have an unusually bright core.
Is
And
that
this
pretty?
is a good
Is that,
photograph of it because this core will frequently burn out or saturate it and turn it completely white when you expose for the arms like this. So whoever took this picture did a good job on processing it.
the brightness?
Yeah.
Didn't they solve the problem years ago of what the heck quasars were? That turns out to be something like this, but on the other side of the universe, wasn't it? Quasars, really bright sources of energy. Isn't that just an overactive large black hole in the middle of a
Yeah,
distant
it's a large feeding black hole, but the axis on which it's beaming stuff out, which is perpendicular to its rotational axis or its accretion disk axis, happens to be pointed at us. So that's why it looks super bright.
But aren't they really distant? Like
Quasars usually were, yeah, but you can have an active galaxy that's pointed towards us. It might not seem quite as powerful as a quasar because it's pointed slightly to one side.
Mhm.
So there's a whole range of brightnesses on them, but it's the same mechanism.
Do we have an idea how big our black hole in the Milky Way is? Is it? On the
It's
4
not
million.
clear that it's not clear it's a black hole.
Oh,
Really? I don't know. I think
Hello?
it's pretty well established as a black hole with about 4.3, 4.4 million solar masses
Yeah.
in our galaxy.
But we read it or we discussed an article that claimed that it was because of the gas cloud that went around it. It was more of a diffuse massive object than a black hole massive object.
Yeah, I don't know that I buy that, but
Okay.
I think needs more evidence.
do you suppose if it wasn't for that gas cloud that's blocking our view of the interior, the middle, it would be fried with
No.
that action? So our galaxy does not host a quasar type
No.
black hole.
It's not actively feeding
Yeah.
at a high rate.
Interesting stuff. Wow.
And even so, to be fried, you'd have to have the axis of the jet be pointed at us.
Now, how many stars are technically in Cetus the whale, since you do those shows in the Gladwin
I mean,
Planetarium?
Cetus the whale covers a huge area of sky. Do you mean
Yeah.
the ones that just make the outline of the whale or all the ones that belong to the constellation?
Well, I don't see where it is necessarily. Wait a minute, Delta Cetus, maybe it does say where it is inside Cetus, this galaxy, because
Right there. There's Tom's circling it.
that the tail up there? or what
Yes.
he's doing?
Well,
You
traditionally
can see
that's
the
the head
red-
of the sea monster, but when you make it look like more like a whale, that's more like the tail.
Mhm.
I see.
So you can see the red dot up there with M77 written next to it.
Yeah.
Oh, yeah, there it is.
And the darker black is the area of the constellation, and then the lines are just the traditional constellation image, I guess you'd call it.
And Bruce Murdoch, you've never gone out and tried to shoot that one.
No, I'm afraid not.
Well, that's your assignment. By next Monday, show us your pictures.
It's
We're
a
actually going to
bucket
go
list
back
item.
up. We're going to go back up Farron Road on Friday.
Farron Road. Never heard of it.
Oh, it's right out here next to me.
Sounds like the name of our hall we used to meet at the museum.
That's Farrand. That's got a D on the end.
Oh, it's a
And it's
different
also
one.
got E's in it. This is
Yeah.
Farren.
And you said Refugio was closed, the whole road or just way up at the top where the Reagan Ranch is?
It just says it's closed. I imagine it's probably open to local traffic only or something like that.
Yeah, because the Alisol fire has been put out for months. Keeps getting
Yeah,
fires.
but then we had a big rainstorm and there was lots of erosion that they have to take care of.
I imagine my friends, the Browns who own the Circle Barbie Ranch out there, are doing okay. They need it open at least to their place. You guys have ever been out there?
Yeah, several times. There used to be a theater out there.
Oh, yeah. Yep. Circle Barbie Theater. Yeah.
They lost a couple of structures, some bunkhouses or something in the fire.
Yeah.
I went on a ride and took a lady with me, and she got the Palomino horse that bolted at the rocky dry creek bed, but I was on the mule that went right across with no problem. in front of her. Had to stop me.
So
Yeah.
I have a question about this diagram of galaxies. Does this still apply the way they're showing the ellipticals and spirals and barred spirals and then irregulars? Does this
they
still?
still-
This is an archaic diagram. I think it was Hubble or Zwicky's guess at how they evolved.
That was Hubble, and he used to think it was an evolutionary sequence.
Yeah,
We're pretty much sure it isn't now, but we still use it as kind of a morphological classification, as you can
Yeah.
see in that, just to kind of identify the shapes.
mhm. Yeah, it lists M77 as spiral, not a barred spiral.
Yeah.
We would be down on still on the green line, but right down there.
Yeah.
What are the odds, gentlemen, of seeing of all the galaxies out there, seeing them face on, swirling, just splattered out? Don't we see most of them on edge? The sombrero.
No. They're in
Really?
all kinds of orientations, so it's just random.
So if you want accuracy face on to 1 degree, you'd have a probability of 2 out of 360.
Yeah.
If our,
Upside, downside.
Yeah,
and if our solar system were located instead of that dinky little Orion spur inside one of the big arms, would the sky be just flooded? More stars to see, you think?
Potentially.
Okay.
but there's also for us, there's also a Goldilocks zone in the galaxy where the environment is not hostile to life on a planet like we have. Some regions of the galaxy, there's too much debris floating around and there's too much radiation.
What would it be like if we were in a star cluster? There'd be no night.
At night.
What? Very bright at night.
Yeah, if you were in a globular cluster, if you are in a star cluster like an open cluster, it probably wouldn't be very much different than now, I'm guessing.
Well, our closest star friend, Proxima,
Alpha
and Proxima, are like 4.5 light years away. If we were in a star cluster like the Beehive or the other one, it'd be what, a light year or less? Light month
The
away?
Beehive isn't that concentrated, really, Ron.
Yeah.
Well, no, they only have 350 stars, but some of the ones we've been talking about in past weeks, which are just,
Those are the globular clusters, like Jerry said. There you have 100,000 stars in a sphere that's 175 light years in diameter.
We'd probably have nearest neighbors of 1 to 2 light years if we were in a globular cluster.
Or even light months if you're way down in the center.
geez.
Yeah.
You suppose any of them are closing in on each other and doing the little,
Yes,
they are.
they change partners. It's a square dance.
And
Well,
some of them get tossed out.
Yeah.
Since you brought that up, can we talk about the last variable star of the month for 2021?
Sure.
It's Algol, Algol, the demon star, cataloged as Beta Persei from the American Association of Variable Star Observers. Sits with Perseus, the hero, nearly 40 degrees high in the sky in the northeast, an hour after sunset, and climbing. Algol is an eclipsing binary. In fact, there's several stars in its system, I think, with one star crossing the other almost every 3 days.
Yeah.
2.867 days. Wow, that's spinning in close, I think. And it dims the star, I guess, from magnitude 2.1 to 3.4.
3.4.
Okay, 70%. Wow, naked eye can spot it.
Yeah.
And there's a nearby.
And they mean not only the star, but the brightness difference.
Okay, but
It's
now
really steep, isn't it?
Yeah.
So that takes place in a matter of, well, if it's 2 hours, 2.7 hours of
No, 2.8 days.
days. Okay.
Yeah.
But then,
So that's
it only lasts a couple of hours for the dimming.
Yeah, that's what I'm saying. That's what this graph is showing.
Mhm.
okay, now is that for both of them or just the littler one to go in front of the
Just the
bigger?
total light you see from the star system.
It's total what? I didn't hear what you said. You broke up a little bit, Jerry.
It's the total light from the star system.
But there's another star. But wait a minute here.
Ron, the third star is very dim, so that doesn't have anything to do with it. But
Oh,
A and B orbit each other, and they happen to pass in front of each other from our point of view. So that's when it dims down. And you see a big dimming when the brighter star goes behind the dimmer star. And you see a smaller dimming when the dimmer star goes behind the brighter star. So you can see there's an extra little dip at the top.
Yeah.
In the view of the light curve.
yeah, right. I can tell what that is. Why is it missing that sine wave in the middle of this diagram, do you suppose?
That's probably when the sun was in that part of the sky.
Oh, okay. And it's called Merfak, the little one.
No,
Alpha.
no. Merfak is another star in Perseus that you can use to compare the brightness.
Oh, I'm sorry. It just says,
It's a reference star.
oh, it's not in the system.
No.
It's brighter. It's at 1.8. That's pretty bright, isn't
Yeah.
it? Magnitude.
And you know, since we were doing some star name stuff, Tom Whittemore likes the star name stuff. Algol there comes from Aras Algol, which means the head of the demon.
Ooh.
So the story is that's the eye of the Medusa monster winking back at the earth. Perseus is holding the head of the Medusa monster.
So
Now, are we-
those
Go
two
ahead.
stars are the head of Medusa.
Yes.
His eyes.
This is a variable star only because they eclipse each other.
Yes.
So variable stars don't just dim on their own. They stay just as bright, but
No,
that's why.
some do, but not these.
Yeah. Variable star is a generic term, Ron.
I didn't get to transfer or transcribe the later part of this piece that Jerry sent. Something about an Algol paradox. Something about a dying star, the companion, losing mass, being sucked in.
Yeah, this is a case where one of the stars sucked mass away from the other. So that kind of solves the paradox. When they first looked at it, they thought, wait a minute, this star is, you know, not evolved enough for its mass.
I see. Okay. Well, yeah, I was going to have you call that back up. So Algol C is the little one that is orbiting the other two, and they're just spinning around each other. The big
Yes.
No, Algol C is an artifact of the camera. It's not a real object.
No, yes, it is an actual star. There's a third component.
There is, but that's
Yeah.
not it.
That's not
The
it.
caption for the picture that I got claimed that Algol C in this picture was an artifact of the data.
Oh, okay.
So
Well, it's
I know
not
it's
shit.
confusing. I got excited at first when I thought, oh, all three components. So
So Algol A is the big one. And and that's our last variable star of the month. The demon.
I use a lot of the internet for pictures and information, and I'm very aware of how risky that can be. So I always double source things and check it. As, for example, the picture of Jupiter's clouds above this in the talking points. It's a really, really nice picture of cloud tops in Jupiter, but it's not a real picture. It's a picture that's been enhanced by data. It's a picture called Jupiter Cloud Top Storms from Juno. It's a Juno picture that illustrates two things they've just decided about Jupiter's clouds from data from Juno, and that is shallow lightning and mushballs. And they've altered this picture from Juno to add in what they believe is going on with the mushballs, those the clouds that extend above the surface, and the lightning that's shown in it. But it's a very dramatic picture. It catches your eye. But you can tell that the lightning has much higher detail than anything else in the cloud. So it's been,
Oh,
the
yeah.
detail's been added. But
Very,
if you
very
go,
fine detail.
yeah, I sent out at Chuck's suggestion, I sent out the more complete article to Tom. And if you look in that article, Tom, there's a nice diagram that shows what shallow lightning and what mushballs are.
Mushballs.
Let me
Mushballs,
find
two
that.
astronomical terms.
Would that be the lightning flashes? That's a
Well,
mushball?
the orange stuff in there and the white stuff in the background, that the orange stuff is the shallow lightning they've got. The fact that the clouds stick up in mounds like this is called mushballs.
Can we not legally show that video?
I don't know about that, but
NASA.
that's not what I was talking about. If you scan
Here it
down
comes.
on this.
Get ready, folks. Strap yourselves in. We're going in. This
Okay,
is
there's the picture. Now keep going down. One more. Keep going there. This is, nope, you passed it. There it is, right there. This is the mushball growth. You see the cloud that's going up. Now this is derived from Juno data. And then a picture was made to illustrate how it would look. Yeah,
Wow.
put the whole diagram in the picture there. There, perfect. So, and you see how the ammonia water core evaporates when it goes down. It shows the stages of the updraft and then the creation of this snowball, and how you get shallow lightning in the center of the column.
Okay.
So these are the new structures, and so you'll be seeing these comments now since this is the first paper to use them. So you're here at the birth of new phrases in astronomy.
The
Wow.
birth of mushballs.
And yeah, and shallow lightning. And if you look just at the Juno images, never mind the enhancements for the mushballs and stuff, but it shows a lot of cloud structure and colors and things that apparently do not mix. And, you know, it looks like you add paint together and you have to stir it a long time to get it to mix to one color, except that never happens on Jupiter. And how that never happens with all these different colors and stuff is really mind-boggling to me. I know it happens in Earth's atmosphere with water vapor forming clouds, and then the regular air being clear, but this is in extreme.
In the physics classes, in the introductory physics classes at UCSB, they used to do a great demonstration of viscosity and friction, where they had a plexiglass cylinder inside a hollow plexiglass cylinder. So there was only like maybe a quarter inch between them. And the central cylinder had a crank on it. And they would fill it with corn syrup, but then they would put a vertical layer of dye, you know, food coloring down one side. So there was a colored stripe in it. And then the professor would take and crank the central cylinder, and you would see that stuff spread out. The color would spread throughout the entire area between the two cylinders till it looked kind of like Jupiter's clouds. And he would count the number of turns he did one way. And then he'd say, watch this. And he'd count back the other way. And it would still look pretty well mixed until right at the last turn. And then whoosh, that line would come back almost, you know, not quite perfect, but almost perfect again. It was really a good demonstration.
Yeah.
Now, those lightning flashes on Jupiter, would they be the size of the Earth? Would destroy us something those sizes, wouldn't they? Or are they about the same as our lightning?
They're certainly very big. I don't know about the size of the Earth.
Well, the video I watched that was sent to me, I kept thinking, you know, we wouldn't be able to see a thing. We would go through an area that seemed to be transparent, and in the distance were other clouds boiling below us. If you got sucked into, you know, you were in a capsule and landed in Jupiter, you wouldn't see a thing.
Oh, I would hate to think about being caught in Jupiter's atmosphere in a capsule.
It would
It
be
gets
pretty,
squashed.
yeah, okay, immediately. Right on
You'd be
the,
whipped all over the place.
the cloud tops.
That's
Can we
300
bring
mile
up-
an hour winds.
Yeah.
gentlemen?
A lot of
you-
stuff that looks opaque from a distance, if you were actually in it, might not seem quite so opaque.
Yeah.
Well, if you would never make it to the center, just like
Yeah.
All right, fascinating stuff.
Well, let's go to Titan's future mission.
Okay, well, let's real quickly. As long as we're talking Jupiter, they're lining up with Venus and Saturn. You want to?
Oh yeah, they're 3 in a row in the evening sky. If you look at the planetarium shot I took or I sent, do you have that up there?
I've got it somewhere here.
Visible in the night sky for about 2 hours after sunset. Hard to miss, especially Venus.
Yeah,
Oh, it's
Minus
bright, yeah.
I picked December 3rd at 6 p.m.
Okay,
And
that's
you can see right in a line, you can see Venus and then of course Pluto, but that's not one of the main 3. Venus, Saturn, and Jupiter lined up like that.
Now, December 6th, you're going to get a really, really super bright Venus right next to a really thin crescent moon. So that'll be really nice to see.
Okay.
Venus is either available morning to night or early evening, right?
Right. And it's transitioning now between the evening and morning sky. So it's diving toward the sun.
Yeah.
Okay. Very good. Let's go to this incredible NASA mission. I guess they're calling it the Dragonfly. They call the unit that they're going to land on Titan, similar to the Huygens, except this is going to fly around and do what the Perseverance helicopter really couldn't do any more than just maybe the.
I sent you a link that shows the a video of it, animation.
Oh, you did?
Yeah, I should.
I didn't get that. I got the tip into.
Yeah, it's in the talking points. It just is a line of gibberish, it looks like.
Oh, okay. Well, it's a robotic rotor craft. They don't call it a drone, but it looks like one. And it's going to the moon of Saturn, called Titan, the one with the atmosphere, intended to be a first ever powered flight on a celestial body.
But this one's going to start at rotors and then fly down and just fly away.
Wow.
It's got eight rotors on it, 2 on each arm.
Mission is proposed for 2026. We got 5 years.
Yeah.
And it's going to land there in 2034.
Well,
Looks like it's nuclear powered.
Oh, it is, okay.
Yeah, see the rear end of the spacecraft or the drone, you see it sticking up like a can. Yeah, that's one of those nuclear thermoelectric, isotope heaters, isotope reactors.
Radioisotope thermal generator.
Thank you. I'll untwist my tongue.
But that whole thing is, no, wait a minute, that's, what does they call those things? The Huygens look like that. Oh, I see, it drops it.
Yeah.
Okay.
And it just takes off, it starts its rotor and it flies away.
And it's probably got more atmosphere to deal with than the little one for Perseverance on Mars, doesn't it?
Yeah, this will be an easier flight regime.
So you think, will it touch the ground and take a sample at all or test or?
I think that's the idea. They there's a list of scientific instruments in the talking points.
You know, interestingly enough, that Titan is so clouded over, it's like the sun would never reach the surface. And yet when Huygens touched down, if you saw that long, descent, you actually saw the shadow of its parachute.
Yeah, it's like dim moonlight at the surface.
Yeah.
It wouldn't be as thick as a cloudy day here when you don't see shadows. Think about it. But this is going to be interesting because those big round blocks were what?
Titan's atmosphere is very hazy. It's like a smoggy day in LA.
Okay, smoggy day in LA.
The first instrument on board is the Dragonfly mass spectrometer, which is going to identify chemical components in surface and atmosphere samples. So it is going to land on the surface and pick up stuff. And it's looking for things that are conducive to life.
Good luck.
Yeah. If there's life as we know it there, it'll be wearing heavy overcoats because it's very cold.
Methane monsters.
Yeah, but there's a speculative, chemical cycle that could be used at those temperatures.
Is methane and water, are they pretty close in chemical makeup?
Nope.
Not at all.
No.
Something I saw.
One has carbon in it and one doesn't.
Oh, that's right. It's CO2. Okay. It's a simple.
So does methane have carbon in it?
Yeah, CH3 or something like that.
Right.
Yeah.
Yeah, I think it's 1 carbon atom and 3 oxygen atoms, isn't it?
No, hydrogen.
Oh,
Hydrogen, there's 4 of them.
The hydrocarbon. Yeah.
Like a barrel.
Water is inorganic and methane is organic.
Organic means carbon, right?
Yeah.
What form does pure carbon take? Is it a metal? Is it a powder? It's not a
charcoal.
gas?
Charcoal.
What?
Yep.
Oh,
Soot.
charcoal.
Soot. Graphite.
Diamonds.
Chemicals.
Diamond.
Diamond. Yeah.
Yeah, the diamond part, I don't get it at all. Look at this.
Well, that's the
sucker.
crystalline form of it. One of the
Dragon-
crystalline forms.
Do you remember those
Graphite.
silly commercials about the what is it, the most interesting man in the world? There was a
No.
beer commercial, and he claimed that he had once made diamond just by peer pressure.
Oh, do remember that, yeah. So we hope we're alive for this, gentlemen. 2034. First proposed back in 2017 in April. Just amazing. And it's part of the NASA's New Frontier program from the Johns Hopkins University's Applied Physics Laboratory. Somebody named Gary Flandro. What are we watching here?
Who
Now,
knows?
the final picture down at the bottom.
Hmm.
Let's move
Sorry.
on to the next one, black holes galore.
Okay, I didn't get much. Oh, there wasn't much to that. They're not stars in the photograph. They're black
No,
holes.
if you look at the picture, it looks like a starry night.
But
But
they're
this
all black.
picture was taken in very low frequency radio waves using radio antennas that were 52 radio antennas that are dotted around Europe. And these are emissions from black holes, from the disk around black holes. And so every spot of light on here is a black hole in that part of the sky. And most of them are, actually all of them, I guess, are in other galaxies. So what you're seeing is black hole emission from other galaxies around. No stars in this.
Wait a minute. So these are outside our galaxies, hopefully.
Yes, well, some may be small. Yeah, they have an accretion disk. They're cores of other galaxies.
Oh, they are?
Yeah,
And we're not seeing the galaxy around them?
no, because this is looking at very low frequency radio waves.
Wow. How many are in this picture?
Oh, I don't know.
I think it said 25,000.
Yeah, that's right.
Can we see them in all directions?
Yep.
This I'm sure this is a sample of the sky, and I'm sure it is the same in all directions. But this is, let's see, where does they tell how big a patch of sky it is? Let me see what that is. 20,002.
Who was our resident expert on black holes? Was that Whittemore or just stars, Cephas?
Yeah, whoever wants to speak up at the time.
Because there's something that happens to black holes. Maybe Hawking's came up with this. They start to lose it later on. They evaporate.
Very slowly.
Yeah.
That, to me, that just goes totally counter to what a black hole is by definition.
No, they don't say the size. I think it's a 20-degree swath of the sky.
Oh, is that okay?
I don't see it written here. That must have been edited out.
And taken by the Hubble, you said?
No,
No, radio telescopes.
Oh, a rate.
It's called the LOFAR, LOFAR, for low frequency array in Europe. It's an interferometric network of around 20,000 radio antennas distributed throughout 52 locations across Europe.
So we wouldn't be able
They
to.
test these light. They do it. They take it simultaneous views, collecting the photons, and they piece it together as if it were a large aperture, a single large aperture. So it gives very high resolution.
But we wouldn't be able to see this with the regular optical telescopes?
Nope, can't see that.
And yet they're black holes.
Yeah. This is, what is it? Let's see, the Scie, the radio frequency to something like,
I thought I saw 500 megahertz somewhere.
I saw 5 somewhere there.
Oh, 5 megahertz.
Well,
Yes.
Well, yeah, but the sky is opaque there.
Oh, wait, that's, yeah.
Ionosphere.
The
Well,
real
the
black.
ionosphere is a problem. You have to look through it. This will be much better when we can do this from space. The frequencies below, at frequencies below 5 megahertz, the ionosphere is opaque. But this is down as low as you can get before 5 micron, 4 or 5 megahertz. So the frequencies that do penetrate the atmosphere can vary according to atmospheric conditions. And so they had to adjust their software to take account for interference with the ionosphere. And there's over 256 hours of data in this and a lot of corrections.
But you're
I didn't
talking-
realize the ionosphere. I didn't realize how thick it was. How many from 50 miles to more than 300 miles in
It's actually
altitude.
not very thick. It's actually quite diffuse.
Yeah, I guess wrong term. I guess how deep it is, or
Yeah,
how much.
how high it is. Yeah.
Yeah.
But now for radio telescopes, we're talking frequencies below the color band, right?
The
Below
what band?
visible.
The colors are higher frequency than what we're looking at. Radio waves. My
Oh,
old
yeah.
radio station job was
Virtually
below.
Everything is above it.
Okay, but I've always heard the real high powered stuff, your gammas and X-rays, came out of black holes.
Well, they do that too.
Okay,
But this
called
was not-
synchrotron radiation. Yeah.
This was not an X-ray telescope. X-ray telescopes can't do this kind of interferometry, but radio telescopes can.
really? An X-ray telescope wouldn't be able to see these same radio images?
Probably not. It certainly would take a long time scanning slowly around and doing it in space.
And the emissions come from the accretion disk, the stuff that's being sucked in.
Yeah, black holes don't actually emit anything, hence the word black.
Except
hear
for that
that.
Hawking radiation that Ron
Yeah,
was talking about, but that's not a bright process.
Huh.
Now, Ron, an X-ray telescope would be able to see some of these sources also. It just wouldn't be able to compile an image with this kind of resolution and this, and easily build up to this size.
I'd like to put things in perspective within the range of what we know. If a black hole were where our sun is, would we be part of an accretion disk, or would they go out that far?
If it had a mass of one solar mass and it was a black hole, you probably wouldn't notice much different, except that days would be very cold out here and there'd be a lot more radiation.
Yeah,
Really?
Ron, you'd have to add something for the black hole to be feeding on for it to have an accretion disk. So you could turn the sun into a black hole and we wouldn't notice it, except for like Jerry said, it would get real dark and real cold. But something like Mercury that's in closer would feel that 1/r² more than we would, and it might start having troubles with its orbit.
But my understanding was there are three basic kinds of black holes. There's ones that's only 3 or 4 solar masses. There's ones that dozens of solar masses, and then there's the big babies in the center of galaxies that are tens of thousands or millions.
Yeah, I think there's actually a continuum of masses would be my guess.
Okay, but
We
they
just
all
haven't found some of them easily yet.
Yeah.
With the gravitational wave observatories, we'll probably be finding more and more in that intermediate range.
supposedly there are a lot of them out there just like rogue planets roaming around our galaxy
Mhm.
in the dark.
So if you ever go out at warp speed, you really got to be aware of what's ahead of you. Gotta have
Really
a
big
black
bumpers.
hole. Yeah.
Fantastic. Learn stuff I learn. I just wish I could keep it. Bruce, are you going out with your telescope anytime soon?
Friday.
Okay.
Go
And
back to Farron Road.
you're having just as many delays in that other club that you're president of, Theater Organ Society, as we have going for us, right?
Oh yeah, we haven't done anything for a year.
Well, maybe
I mean,
we'll
we
have
publish a newsletter and have a website, but we don't meet
Oh, you-
physically.
Oh, you do publish a newsletter. So why don't you send us all a copy? Love to
I
read
can.
it. Well, I mean,
Sure.
we're sort of what, ad hoc members or proxy members, if we know you. In any event, we're down to the wire. We learned a lot. I don't think we missed too much. Oh, the James Webb is going up 4 days later. They think it'll actually go up on an Ariane rocket out of French Guiana. Do you suppose the first orbit after it leaves is right on the equator? Since that's where that rocket base in South America is, it's pretty near the equator. Because our launches,
It would have a low inclination, yeah.
Yeah.
okay, our launches from Vandenberg and Canaveral are always that wide sine wave down south and then back up.
South.
And wondering if that's
Over the open ocean.
yeah.
You know, the James Webb is going to head for that Lagrange point. And
I'm sure it's-
Lagrange point is in the plane of the Earth's sun. So it's going to be launched pretty close to the equator.
Man, there's so many things that can go wrong with that baby.
What do we have, a 20-degree, what's the tilt of the Earth's axis, 24 degrees?
Yeah, 24 and a
22 and a
half,
half, isn't it?
23 and a half.
22 and a half, yeah. So it's going to try and stay in the plane of the Earth's sun, which will be off the Earth's equator by 22 degrees.
And it's got some 300 things it's got to do, unfolding tennis.
Yeah, it's an origami. It's our first origami space probe.
And for 30 days, they're going to be holding their breath, which is what we're going to do for another week. That's episode 40. Gentlemen, thank you. We missed you, Tom Whittemore, but Bruce, thanks for joining us. Keep us appraised of what you're doing. You guys take care of your
You're welcome.
wives.
Thank
Jay
you.
and Chuck and Tom. We'll see you next week, literally on the screen, and hopefully return in January to our museum second Saturday. Bye-bye, everybody.
January, second Saturday.
All right, Ryan.